Welcome to this tutorial on bonding. We're gonna look at some exam style questions and you're gonna get the time to practice these questions. So to really try to, write down following the marks and really try to answer as if it was an exam question. And then when you're ready for the solution, you're gonna play this video again and you're gonna check the solution that I give you, which means that you're gonna pause when I say and then play again once you're ready for the solution. So this is the first question. Let's get started. So if you play, it means that you tried the answer and like the question and you're ready to mark it. So very important for this question, apart of these 5 marks, so we need to really know where these marks are distributed because very open question. But notice that also you have many indications of what to say in this open question because it describes what happens. 2 atoms, it's highlighted, it's going to mean something. React with 1 atom of sulfur gives your answer in terms of electron transfer. So it's a very important and give the formula of the ions. Notice that these are going to be like short marks because it's so stated clearly in the question that you have to say that. Okay, so the key point to say is that each potassium loses 1 electron to form a 1 plus ion. Sulfur gains 2 electrons to form 2 minus ions. So this is very clear in terms of formula of the ion. Transfer, you can write it either all together in a nice structured sentence, but as long as you say something like each potassium transfers 1 electron to the sulfur. So those are, as you can see, the 5 points. The fact that what loses, what gains, the formula of the ions, and the transfer. So make sure you mark it and notice where you lost marks. Maybe it was in the interpretation of the question, maybe it was about the knowledge. And when you're ready, pause if you needed more time. But we're going to go into the next question. Pause and play when you're ready for the solution. Okay, if you've played this because you're ready to see the solution, dot and cross the diagram. Very important here. I hope you opened your periodic table because you do really need that to do this. And also remember that dot and cross the diagram can be of different bonds. So you need to identify which bond is that first. It's covalent, okay? So we have the nitrogen. It's our central atom. We know that nitrogen has 5 electrons because it's in group 5, so 1 electron on each side. And then chlorine, it will share 1 electron with the nitrogen because we know that chlorine has 7 in its outer shell because it's in group 7. Okay, so we know that it needs only 1 to have this magic number 8 so that it's stable. So silicon is in group 4. We have 4 electrons in the outer shell. Remember to write each electron on separate side. Chlorine, it has 7 electrons, so it needs only 1. It's gonna share 1 with the silicon. And we write the other 7s, remember, always paired. And here is the chlorine. So different ways to work out the dot and cross diagram. Yeah, if you got it wrong, remember to maybe check more example in our lessons. Okay, all right, I hope it's all clear in terms of looking at the periodic table. So remember, the group number tells us the number of electrons in the outer shell. And then we need to think about how do we get to 8? How many do they need to share? I hope it's clear. Double check that you got the number of electrons all right and make sure you have 1 dot and 1 cross. And if this is clear, next question, again, covalent. Okay, play when you will be ready. I know the nitrogen is a particular tricky one to do the dot and cross diagram, so let's see if you got it right. Now, I will do it separate to show you like what to do when you get stuck with the dot and cross diagrams. Write down two nitrogens because that's what you have, no? And write down just the outer shell electrons. So now this first nitrogen has 5. The other, well, both nitrogens obviously, they have 5 electrons. Remember that I write them down like this, separate first, and then I pair them up. This will show you that nitrogen will need to join 3 electrons with each other to have a full outer shell. In fact, there will be 6 electrons shared between them. This is a triple bond, okay? And then, of course, remember that each nitrogen still has a lone pair of electrons. Other examples that are a little bit complicated like this are oxygen, because oxygen, it has 6 electrons in the outer shell, so it's gonna have to share 4 with another oxygen, showing a double bond, okay? Carbon dioxide is the other example where carbon has to share 4 electrons with it, sorry, in total 4 electrons with oxygen, because, well, oxygen needs just the 2 electrons to bond. Oh, this has to be another, well, this would have to, no. Anyway, so triple bond, double bond when there are 2 pair of electrons, triple when there are 3 pair of electrons. And this is the first dot and cross diagram, very likely to be 1 mark. Explain why nitrogen is a gas at room temperature. Nitrogen structure, this is the hint. What is the structure of nitrogen? Well, it's a small covalent molecule. So small covalent molecule, they have weak intermolecular forces. We can say of attraction. Very important is between the molecules. Because you're not breaking the nitrogen-nitrogen bond, you're breaking the force between the molecules. How is that relevant to being a gas at room temperature? So little energy is required to overcome the forces. Okay, structure, small covalent, weak intermolecular forces, little energy required to overcome them. Okay, take a moment to take in the answer. I know it's quite difficult dot and cross, and well, this is very important to learn, about these small molecules. And remember, this is just for the covalent molecules, because there are also giant structures, and this would be slightly different. Okay, pause if you still have to write down, otherwise I'm going into the next question. Okay, another one of covalent. This time we're talking about different structures. So once again, we have 4 marks, so it's quite open. Answer in terms of structure and bonding. So you will see that this is really the key points, of this question. So rapid and fullerene forms of carbon, soft and is good conductor of electricity. So notice that the marks are clearly for these explaining these 2 properties, and then in terms of structure and bonding. Okay, so it's important that you do this analysis for every question that you come across, because like, did you make sure you plan a little bit your answer? So this is useful for the bit more open questions. Now, we are talking about graphite. If you remember the structure of graphite, it's layers of, and I'm just gonna do 2 layers to not spend too much time drawing, of graphene. And these layers are connected by intermolecular forces. So here I've kind of said already the name. So first of all, in terms of structure is a giant covalent structure or lattice, same. Okay, Covalent would be the bonding, giant covalent structure, yeah, with weak intermolecular forces between layers. Okay. So you could also say that it's carbon bonded to 3 other carbons in a giant covalent structure. Okay, remember that it's not sticking to like just 4 specific marks. Sometimes the mark scheme is also it has more points, you know, that can be set. For example, this one bonded, as long as you say covalent and then the structure, the giant structure. And now we can look at the properties. Why is this soft? Because the layers can slide. Okay, because of the weak intermolecular forces, and a good conductor of electricity because it has delocalized electrons through the whole structure. So the conductivity is very specific in terms of the delocalized electrons. The reason of that, remember that carbon has 4 electrons in the outer shell, but in graphite it's only bonded to 3, which means that there is 1 spare electron for each carbon. And that's why it's delocalized, just like in a metal. In fact, you know this, that graphite is used in, for example, electrolysis instead of the metal. Anyway, we take a moment to see if you got the 4 marks, and if not, we'll move on. And if you're ready to move on, we're going to the next question. Let's go. Okay, the last open question for this tutorial. I hope you have tried it, you've attempted, so 4 marks. Okay, once again, the analysis of the question: describe the bonding in metal and explain. So describe, explain, yeah. And then is in terms of bonding, and then the property conduct. So we can see already where the 4 marks are distributed. Okay, so describe the bonding in metal. We have giant metallic structure for the structure, okay? And the bonding is, I would always say, if it says specifically the bonding is an I would like describe the bonding, define the bonding, always do it in terms of the electrostatic attraction, okay, between. Those are all the bonds. And then it changes what the type of bond. So it's between the positive metal ion and the localized electrons. Explain why conduct electricity. It would conduct because the delocalized electrons, this is the mark, are free to move or flow through the whole structure. So as you can see, 4 marks about the giant metallic structure with electrostatic attraction between the positive metal ion and the delocalized electron, conduct electricity because of the delocalized electrons that are free to move. So just think the localized electron doesn't explain well enough why it conducts electricity. So we need to say these flow through the whole structure. Well done for this tutorial. Okay, I hope it's all clear, but we've really seen the structure and the properties in, I think, in a very nice and complete way.